Alright, hello everyone. Today we're going to be looking at some graphs of linear motion. So if we look at this first one here, we have displacement on the y-axis and time along the x-axis. Okay. Remember, S stands for displacement. So for a displacement time graph, the gradient, so this section here, if we find the gradient of that section, that will give us the velocity. Okay, because remember, gradient is equal to rise over run, which is equal to displacement over time. And displacement over time is velocity. Okay, so the gradient represents the velocity. So if we have a steeper gradient, if the gradient was more like this, then it would mean we have a higher velocity. But if we have a horizontal line, which we do at this point here, it's horizontal, then that indicates that the object is stationary, or it's not moving, because there's no further displacement. Okay, and one more thing is the y-intercept. So at this point here, where it crosses the y-axis, for this one it's 0, 0, but for other graphs it might start up here and then go up this way. That just represents the initial displacement. Usually that'll be at 0, 0, but sometimes it can be not at 0, it can be higher. Okay, now let's have a look at velocity time graphs. Alright, so now we're looking at a velocity time graph. So the gradient for a velocity time graph, so look at this one. This will be a gradient here, and there'll be a different gradient over here as well. So we'll get two different gradients for this one. Now, if the gradient is positive, so if it's increasing, if it's going uphill, that means the object is speeding up. So positive gradient means speeding up. I'm just going to put M for gradient. Now, if it's a negative, that means it's slowing down. So if we look at our graph now, we have a positive gradient at this point here and a negative gradient at this point here. So the object was speeding up, then it stayed at a constant velocity and started slowing down again. So that's what's happening there. Okay. Now the gradient represents acceleration as well. Okay, so you probably could have guessed that, because if we have a positive gradient, we have a positive acceleration, which means that it's speeding up. So gradient equals acceleration. Okay. All right, so the y-intercept shows the initial velocity as well, just like the initial displacement for the previous one. But important thing to remember here is that we have a constant velocity here. So there's no acceleration here, we have constant velocity, but the object hasn't stopped moving. So if this is a car, for example, this first purple line on the left, that will represent the car speeding up, let's say to 60 kilometers, and then the car stays at 60 kilometers for a period of time. That's this blue section. And then the car comes to a roundabout or something, and then it starts to slow down or decelerate, and that represents the next section there. Right? So hopefully that makes a bit more sense. There is some more things you need to be familiar with for these graphs. So this one, we also can calculate the area under the graph. So the area under this graph, this section here, is equal to the displacement. Okay, displacement, or S. So the area under this velocity time graph is displacement. Okay? All right. So when you find these areas, usually you only have to find it using simple shapes. Like for this one, you probably could, because it's a pretty simple shape. But it would just involve simple geometry. Okay. All right. Now the area under an acceleration time graph is equal to change in velocity. So that's another thing to be aware of as well. Okay.